The next question uses the same function with the same graph. Here's a simplified version of that graph. The y equals x squared graph shifted 2 units to the right to give us the y equals quantity x minus 2 squared graph. We go to the x equals 3 point, which, as we saw in the immediately preceding video, was 3, 1. And we're trying to get a rectangle we want the area of a rectangle whose vertices are at the origin and at that point 3, 1 with sides parallel to the axes. Now, people had trouble doing this, so I drew 2 points on the board and asked to construct a rectangle with sides parallel, well, with vertical and horizontal sides. Let me do that once more, just to make sure we understand the logic of this. We have a point here and here. Okay, we want a rectangle where these are 2 of the vertices or 2 of the corners, and the sides are either horizontal or vertical. So, well, a vertex is where 2 sides come together. So we have a vertical side here coming together with the horizontal side. So the vertical and horizontal sides will be somewhere along this line. Maybe out here, maybe up here, somewhere. There are 4 possible rectangles. This could be, or 4 possible directions for a rectangle of which this point could be a vertex. There's one up here, one here, one here, and one here. Which one would it be? Well, let's do the same thing for this point. Okay, we draw a vertical and a horizontal line through the points. And now, where's our rectangle? Well, we can see it right here, smiling right up at us, or down on us. We don't know where it is. Okay, so there's our rectangle. Now, how do we do that with the points 0, 0, and 3, 1? Well, I've already drawn it in because I drew it in class. But we see that the rectangle is here. And the dimensions are then 3 in this direction, 1 in this direction. That would seem pretty obvious to everybody. And the area was then 3. Okay, well, we do the same thing for the point 5, 9. We get a rectangle 5 by 9. Okay, now we do the same thing for the point a minus 2 quantity squared. That's the x equals a point on the graph. And what do we have? Well, from here to here is a, because of course the x-coordinate at this point is a, and the y-coordinate is plug a into the function, and we get a minus 2 quantity squared, same as we got before. So here's the point, and here's the origin. Here's our rectangle. What are its dimensions? A by a minus 2 quantity squared. So the area is a times the quantity a minus 2 squared. And if we work this out, we can expand it to a cubed minus 4a squared plus 4a.